The next startup is Musashi, and I welcome Martin Buffy, and he's going to talk about an AI model architecture designed to solve common deployment challenges. So Martin, the floor is yours.
Thank you so much. Good afternoon, everybody. My name is Martin Buffy here, representing Musashi AI. And I hope in these next 8 minutes I can convince you and maybe entertain you at my booth so we can talk more technically about what we're doing here at Musashi AI. I'd like to begin with a little quick background about Musashi Sumitsu. At the heart, we are a manufacturer. We've been doing it for over 80 years, and we do it for all mostly automotive parts. We're worldwide, so we take data super seriously. There was a very big need on automating 40% of what we do day to day, which includes self-driving vehicles and movement of things, and as well inspection. Very high labor intensive with non-value added. When we began this new venture of Musashi AI, we found that one of the biggest challenges in delivering AI is the ability to make it accurate, reliable, and cost-effective. And the thing that customers want is something that works on day one. Everyone here who develops AI understands that segment, and they'll probably understand the pain points that I label out here, so that maybe there's some new ideas and discussion that can happen. For anyone who's working in this space, they understand that the typical setting of how computer vision AI work cycle goes is you start with a POC, you do some model optimization, you deploy that model, do a rinse and repeat cycle, and then you do maintenance and support. But, hello? Oh, OK. But certain challenges begin. There's the scarcity of data, model training requirements, multiple defect classes, rare defects and anomalies. There's complex surfaces. There's surfaces that are shiny and irregular. And then there's also the false calls. And that happens with environmental factors, surface imperfections, even just the dirtiness of a manufacturing environment. For instance, I brought here an example of a camshaft. This is something that we've done inspection on, and it's very complex. You can see, based on that, there are over 15 regions of interest that we need to inspect. There's over 20 different types of defect classes that can happen. Everything needs to be measured to a precise amount. And even the ability to understand assembly and feature presence is very crucial. Imagine trying to create and collect a data set that could do all of this in real time in a segment of 3 months. Very difficult. Don't take my word for it, though. Based on the Manufacturers Alliance survey, one of the #1 things that stops manufacturers is the data. And only 11% of them happen to be data mature. So I listed it out: scarcity of data, complex parts, and false calls. There are the typical ways of doing and getting around these things, like collecting more data, optimizing optical setups, and experiment with different neural networks. All of this takes a lot of R&D time. All of this is very labor intensive for the AI teams. But let's step back for a second and let's say we've collected that data and we've trained a really good model. Everyone is super happy in the POC. Let's go deploy it. Let's say there's bad issues with it. What can be the problem? New defects classes in production that are not in your model. Sludge, casting cracks. You guys think about software bugs. We think about real bugs on our camshaft. And so who expects something like that to happen? Well, with traditional machine intelligence, most of that would be a defective camshaft. But you need to use AI there to understand that that part is not a reject. That part can just be simply cleaned. One model architecture may not actually be able to do all the inspection requirements. Defect analysis, measurement, assembly verification, all in that process with training could dilute its performance. And lastly, again, environmental factors in both the variation of good and NG parts when it comes to manufacturing, again, can be a very big problem that you need some higher order system to be able to solve. So again, what are the main issues that are seen across the industry, not just with us, is false calls is #1. Incidents being a good part marked as defective or vice versa. And second is the inability to deal with complex surfaces, inspections, and variations. Many cameras you see on the market right now require the part to be almost identical every time. But you need to use AI in order to understand those variations and understand when it is truly an NG and truly an OK part. So Musashi and the engineers decided to go out on a new journey to create a new architecture where it takes the best of both anomaly detection and learning what NG parts are, and takes the best of supervised learning with object detection and merges them together. Here we have the ability to start with only 30 to 50 good parts, and then we're able to use the anomaly detector to then correlate what the object detector sees, and the two of them have a discussion on whether what they're seeing is in alignment or not. But imagine that same part goes through the line and now there's a purple paint. What do you do? That may, if you're just purely using object detection, that actually might not be caught. You've trained it to ignore specific things due to sludge and all that, and now you've missed a crucial defect that's on the images. So by bringing them together, by bringing them together, we are able to then collect all types of anomalies and train our new system over time, continuously with active learning. Another big portion of this is being able to do explainable AI that allows us to understand.
I'm sorry, just wait 1 minute.
It's very important. OK, so with the ability to use explainable AI, we can understand what types of defects we want to put into the system to improve the system and make sure that there's no model drift. Mind you, all this is happening on the edge, no cloud processing, no data leaving the service. We had so much success with version 1 using object detection and anomaly detector that we've actually improved it to use now instance segmentation. We are now pixel by pixel understanding what is the type of class that we're looking at. And then we bring in the anomaly detector too to provide more insights and more capabilities to the entire AI system. Again, all running on edge devices, optimized and quantized to run in real time for the production lines. So hopefully, with that understanding, we can go back to this quick chart, and you can see that with the scarcity of data, we're still able to deploy day one. And day one, we're able to start actually collecting data that's in a real production setting, not in a lab. We're actually also able to continuously train day to day and optimize those models so that both models, when they communicate together, are able to come to proper resolutions and make sure that we're not just labeling parts as OKNG. We have a multitude of different ways, because this is what humans do. If humans are unsure about something, they go see someone who is more sure to double check. Second, complex parts and surfaces, again, by using two different models, we're able to utilize both of their understandings to actually come up with the proper end inference. And lastly, false calls, again, multiple models allowing to do an ensemble to allow us to be able to fuse what their outputs are and get a better inference. I'd like to also invite you to our booth. We're showing this. We have camshafts, and we are able to explain this more in technical detail. So this is our booth. And after all that, if you're still uncertain about AI or you don't believe me, come and download our app or come visit us here. We'll show you how AI, even in the presence of different lighting conditions, different part orientations, can still adapt and understand what it's seeing on the part. Here, we've built an iOS app that uses models that we've actually trained already on inspection, and we've quantized them and put them into a version in iOS that allows you to run them on your device. Doesn't matter really the iOS device, and allows you to see what AI is seeing in a real-time fashion. It's a very cool demo, and I encourage everyone to see it and try it out. And we'd love to hear your feedback. Thank you so much.
Thank you, Martin, from Musashi. Do I see a question from the jury members? No?
OK.
So, Patrick, you have a question, please.
What's your business model? How do you gain revenue?
So we are mostly
like
a software
as
company.
A service.
So we develop the complex AI systems for the not low-hanging fruit of the manufacturing industry. We use these models in our custom-built software and then deploy them with our own either engineering staff or our integrators that will use our platform to put it into the specific other companies' manufacturing lines.
Is it like software as a service, or is it a project-based
It's
approach?
software as a service.
Okay, Martin, thank you.
Thanks so much.